Okay, so in this case, we're going to get more incorporation with more length, but there are definitely times when you'd like to, instead of measuring the amount of nucleotide incorporated, you would like, whether you make a 10 base pair primer or whether you make a 10 base pair product or a 1 kb product, you'd like them to be labeled the same. And when you want to do that, you use a different kind of assay. Okay, so this is different from an incorporation assay, and it's called a primer extension assay. Okay, the only difference in this assay, oh wow, I could have not even changed this. So this is our single-stranded DNA circle. We're going to have a primer still. And the only difference now is the thing that's labeled is our substrate. Okay, so we've incorporated a fluorophore or we've incorporated a radioactive nucleotide into the primer. Okay, so this is the same 5' 3' OH primer that we talked about. So you make a labeled primer template junction, okay? And typically that label, well, the label has to be on the primer. Okay, because that's going to be part of the product after you finish synthesis. Whereas the template, once you separate it, will no longer be part of the product. Okay, so you can do this reaction exactly the same. Okay, so you can perform the reaction and you can even measure by either filter binding or gel separation. If you measure filter binding, what you would, I'm wrong. You cannot use filter binding. Yeah. Why can't you analyze by filter binding? If you had absolutely no DNA polymerase, what result would you get? You get lots of bound DNA that was radioactively labeled, right? If you made full synthesis of the entire thing, you get lots of products because basically the starting product and the ending product would have the same amount of label on them, okay? I should point out one thing. This is what I forgot to say. You do not label the DNTPs. Sorry, okay? So we've changed the label. It's on the primer now. The DNTPs are fully unlabeled. Sorry. So that's the primer extension assay. Can analyze by filter binding, can by gel separation. So what's that going to look like? So if you look at that, by ethidium bromide, it's going to look exactly the same as the previous one because we're doing essentially the same reaction. Okay? But if we look at the radiation or the fluorescence, we'll see longer and longer products, but the intensity of them will stay the same. Because whether you make a 100 base pair product, a 1,000 base pair product, or a 5,000 base pair product, they all have the same labeled primer associated with them. You're not incorporating new label. Okay? Does everybody understand the difference between these two?